Okay, let's check out an application of this logarithm equation. It says the percentage of adult height attained by a boy who is X years old can be modeled by this logarithm equation or function. X represents his age, f of x represents the percentage of his adult height. Approximately what percentage of his adult height has a boy attained at age 8? So what they're doing here is they're giving us an age, and x represents years old, so all we're going to do is plug in 8 and see what happens. So really we're just finding f of 8, which is 29 plus 48.8 log of 8 plus 1. And we'll just go to our calculator and make that calculation. Lost my calculator again. So let's type that in, and that log is log base 10, so that's one we can do on our calculator. Okay, let's clear that out and find out where our function is. (29) plus 48.8 log of x plus 1. And let's enter that and see what we get. So it's 79.81. So at age 8, we can interpret this that a boy is at 79.81% of his adult height. You know what might be interesting is to see at age 17. A 17-year-old is at what percentage of their adult height? We can go here and do the trick that I've been working with, going second calc, retype that in, and let's put in, oh my gosh, hold on. I put an X. I didn't need an X right there. I needed an 8. Uh-oh. Okay, let me come here and do this one with the 8. I wonder why it even gave me a value with an X in there. 75.56. Okay, I'll come back and make that adjustment. Now let me do it for a value of 17. Let's say the kid is 17. (48.8) log of 17 plus 1. 90%. Okay, let's get that down. This one is 75 and 90. So this one is 75 and this one is 90. Sorry, I plugged in an X. Forgot to put in the 8. Told you to plug in an 8, but I didn't. So an 8-year-old boy is at 75% of his adult height. At age 17, a boy is at 90% of his adult height. And it makes sense. As you get older, you're getting closer and closer to your adult height. So there, application on logs. Now let's play around, or not play around, but let's talk about the graph that I mentioned earlier, with your exponential function being here, the whole one-to-one business flipping over this line, y equal to x, giving you the logarithm function. So this is something I mentioned earlier. Exponential. This gave us the log. And about the log function, we have that domain. Here the x is greater than 0, the domain for a log. The range can be anything, but the domain has to be x greater than 0. You can see some ordered pairs were plotted. F of x equal 2 to the x, we plotted these earlier. Comparing a table of ordered pairs, what we see is the x values for the function all become the y values for the inverse. And the y values for the function become the x values for the inverse. Remember that swapping of x's and y's? Well, it happens here. So I could take the ordered pairs from the exponential function, swap them out, and get ordered pairs for the log function. And that could enable me to graph them. One way to graph it. Your basic shape of your logarithm, we'll take the one that I have here. Basic shape, it's kind of arcing out. It does have a vertical asymptote. You can't forget about that. Vertical asymptote at 0, x equals 0. The domain has to be 0 to infinity. You can't take the log of a negative number. Domain is 0 to the right. Range is going to be all real numbers. Vertical asymptote at 0. Now if this guy is shifted left or right, we have to shift the vertical asymptote left or right. So if there's a left or right shift, we have to also shift the vertical asymptote left or right. So we have to pick that up from our function. Just another note, can't take the domain of a negative number. We tried it earlier, saw that we had a problem. So let's just state the domain, range, and asymptote for this logarithm. We know it's just a basic logarithm, but let's check out the shift. Inside the parentheses, I have an x minus 3. And whenever your value came inside the parentheses, that was a left or right shift. Since it's a minus 3, it's going to go to the right 3. That means I'm going to have a vertical asymptote over here at 3. That answers the asymptote question. What about the range? Don't even stop and think. The range is always all real numbers. The domain is going to be, it's going to use this vertical asymptote, and in this case, the domain, the x values, will be greater than 3. If it had been flipped over to the left side, then it would be the x values less than 3. So find the vertical asymptote and just shift that basic graph over, in this case, to the right 3. This would be 1 point more than 3, which would be 4. That x-intercept would be 4. So there's the domain, there's the range, asymptote, x equal 3. What direction is this one shifting? That one's going to the left 2. So that tells me I have a vertical asymptote that's going to be left 2 units. Oops, let me draw that as a dotted line. Vertical asymptote, left 2 units. The log function is just going to be next to that. If this is 2, then it's going to cross there at 1 because we just did a basic left shift. Domain is everything greater than that asymptote, negative 2. Range, do you need to think about it? No. Range is always going to be all real numbers. And finally, the vertical asymptote, x equal negative 2. Okay, let's think about this one. This indicates a shift up 2. Does not affect the vertical asymptote. This tells me we're going to reflect. and we're going to reflect across the x-axis. So let's use those transformations to help us. The normal logarithm function has a vertical asymptote at 0, has this point at 1, and arcs out in that direction. This is normal. That point is at 1 and this is at 0. Now let's take that normal logarithm shape and reflect it across the x-axis, which is here. And once it's reflected, let's move it up 2 units. So I'll show the reflected shape in this light blue. So if this thing flips over the x-axis, it should look like this. There's the reflected shape. Still at the number 1. Now let's take this blue reflected shape and shift it up 2 units. So that means this point right here at 1 is going to become what? This is 1, 0. So if I go up 2, it's going to be 1, 2. Take the blue shape, shift it up 2 units, and you will get a graph that looks like this. Quit that. This point was at 1, 0. If I shift it up 2, it's at 1, 2. It's this blue graph shifted up 2 units. Final graph would be this pink one there at the end. So we can use some transformations to graph those.